The last topic we will cover in this chapter is enumerated types. Enumerated types is a way to create your own data type. So we have the primitive data types. These are 8 different data types. And once you declare an integer, you can only store in it just integers, right? So a similar way is to create something that is outside these 8 primitive data types, but it's something that you define. It's your own data type. The way you define an enumerated data type is to use the keyword enum. All right, so if we have a look here, this is what we use as a keyword enum, and then you call it whatever type name that you want, and then you start to list one or more enum constants. All right, so an example of this is to define a data type called day. All right, so we know that we have integer, we have float, we have double, we have boolean, we have char. You could define something called day. It's a data type that you declare. The way you do it is that you define enum keyword day, and then you start to list the possible values that this data type can take. All right, so this means that if I declare something called day, all right, a variable that is of type day, it couldn't take any value outside this list. Similar to declaring a variable that is int x, it cannot take any value outside integers, right? The group of or the set of integer numbers. All right, so that is the same way. So here I'm defining them as Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now, one thing you will notice here is that all of them are uppercase. This is not required, but it's naming convention. It's the way, the standard convention for writing. But you don't have to do it, but that's the common thing. All right, so once you declare this data type for you, what you can do later on is that you can declare, or you can actually declare variables that will be taking values out of this data type. So I could define a new type, a new variable workday of type day. And this workday is going to be the value day dot Wednesday. All right, so here are a couple of things. First, the first part of this looks like any declaration statement, right? You have the type and variable name. And then this second part doesn't look like anything that we have dealt with before, right? So it's not a primitive data type, it's not a class, but it's the name of the type dot the value from this list. All right, so this is how you declare and assign a variable from an enum type that you declared. All right, so how does that look like? So this is exactly what's happening in the memory. You have a data type or a variable, which is going to be called workday. It has an address that is going to point to one of the possible enumerated values defined in this data type that you just declared, which is day. All right, so if you make it point to day dot Monday, this arrow will be pointing to Monday, like this. All right, now one thing that you will need to understand here is that enum can be considered as a special class. All right, and this is very important to understand, and I will show you some kind of a proof of that this is actually true. Now, when we say, the reason why I'm saying it's similar to a specialized class, you can be considering it as a specialized class, is that this automatically makes these, all right, objects. So if enum is a specialized class, then this means the class members are actually objects. And what does that tell us about objects? Since they are objects, what does that mean? It means they have methods. All right, Now, if you look at this, you will find that any enumerated type have the following methods. It has the toString, which is going to print the contents. It has ordinal, which is going to tell you the order of that object in the list that you enumerated. So for example, here, if you look at this, that is here 0, this is 1, 2, 3, 4, 5, 6. All right, so 7 days. So here, ordinal is going to give you that integer, the number that represents the place of that object in the enumerated type. So that is the ordinal value. Equals is going to compare. Compare to is going to compare, just like strings. And this is going to give you the positive or negative or the 0. Here is going to give you true or false, right? So let's see an example here. So if we check the code, my mouse is acting up. All right, so if we check the code here, there's an example, and this is the example provided by the book. So we create a class called Enum demo, and here what we are doing is that we are declaring our enumerated type called day, and it's keyword enum day, and then curly braces and listing all of the contents with a comma. So this means whenever you declare a variable of type day, it has to take one of these values. It couldn't take any other value. All right, and it's also case sensitive. So for example, here I could go and say day workday is equal to day.Wednesday. All right, so I couldn't go and say, for example, here day dot Wednesday. If I try to compile this, I would get an error. Cannot find symbol variable Wednesday. All right, so it has to be matching the case in the declared enum. So here I'm defining workday to be day.Wednesday, and then I'm going to print day.Wednesday. All right, or I could also print day.Wednesday to string. All right, then I'm going just to list all of these things, and then we are going to run and see the outputs. The ordinal value for day.Sunday is, and here is dot ordinal. So this is how you are using it. You see here, so it's day.Sunday. If you are going to assign, it's day.Wednesday, and if you're going to call a method, it's day.Sunday dot ordinal. Right? It's here, for example, again dot ordinal. Right here, I'm comparing things. If the ordinal of Friday is greater than the ordinal of Thursday, compared to, and I'm comparing it to greater than 0, so I can get true or false for the if statement. So nothing really new other than knowing that this is the keyword, this is how you declare it, this is the data type, and how to assign or to create a variable out of this, an object. So here, if we run this, this is what we get. Wednesday, because that's this. All right, I'm going to string compile. There we go. All right, the ordinal value for day.Sunday, all right, which is Sunday, is 0. That's the first day here. The ordinal value for Saturday, which is here, is going to be 6. And notice here you say day.Saturday is going to print Saturday. If day.Friday ordinal is greater than day.Thursday ordinal, Friday is greater than Thursday, then print that day.Friday is greater than Thursday. And here compared to is going to give you a positive, right? So day.Friday compared to day.Monday, right? So here, if I take this and try to print that, four. All right, so we're comparing Friday to Monday. So this is 1, this is 5, right? And the difference is 4. So that here compares and gives you 0 or greater than 0 or less than 0. So that's how you declare it. It's a good way to limit. So for example, you're going to declare a field in a complex aggregated solution that you are creating here, and one of the fields is going to be a day, and you know that the day is not going to get out of these 7 options, right? So instead of keeping it floating, that some people write it Sunday, some people write it as an S, or Sunday or lowercase, Sunday or uppercase, you can limit it to be a data type. You can have a data type of day, and it has these values. The one more note, you remember I said it's a class, special class, makes all the contents being objects, which means each of these objects has its own methods, and this is what we are showing here. Again, to see that it's actually like a class, you can actually see here that I could go and declare enumerated data type in a single file alone without even containing it in a class, because it, in its own, it's actually a special class. So here in a single file, like in a file, the Java file, I go and type enum car color red, black, blue, silver, gold, and then I go here and I try to create car color cc is equal to car color, the name of the class or the enum type, dot gold, and then I try to print this here. It's going to compile. You see the connection here, and you see here it's actually going to work. So that is some kind of a proof that enum can be actually considered or treated as a specialized or a special class. All right, so that is something to think about. And here you can see we can actually declare it within a class or declare it separately in its own file. All right, and that's process actually, we are not going to cover it in detail, but you should know that you could actually define a class within a class. All right, so that's something, it's like nested loops, nested if statements. You have nested classes. You can define a class within a class. And you could do this if you need that class only in the context or within the scope of the outer class. All right, because otherwise nobody outside will know what the day data type is, right? But now everybody can see the day car color, sorry, the type car color. So that's the difference between nesting it within a class or writing it separately in a separate class. So that's it. That concludes chapter 6. If you have any questions, please let me know, or send me an email, show up on office hours, or any way that to get me the question, and I can help you. Good luck.